Theodore is not super interested in probability, so he is hiding, but I'm sure all of you will be excited to be here. And we're going to introduce probability with just some definitions. This video is I hope this video is kind of quick, just a little informal, talking about some terms that'll pop up. We're really going to work with more of these terms later throughout the section, but this is just kind of a little intro. Okay, and the setting for these definitions is this example where we have a sample of 10 jelly beans of different colors, and we're going to draw one random jelly bean. So to find the probability of an event, the probability of something happening, again, that's what this is, probability of an event. The way that we find a probability of something happening, as long as everything has the same chance of happening, we're just going to count, well, how many outcomes make up that event, and what's the total number of possible outcomes. This is exactly what we've been doing. Remember when we kept saying proportions and probabilities? It's because it's basically the same thing, as long as things don't have other chances. So again, this is if outcomes all have the same chance. In the next unit, we'll talk about what happens if this is not the case. All right, so in this case, right, there's two different purple jelly beans. But for the purposes of our situation, if we're curious about what color we draw, we don't care if we draw this purple jelly bean or this purple jelly bean. The event of a purple jelly bean has two outcomes, this purple one and that purple. Okay? That's what they're kind of talking about here. Oh, also, apparently I'm drawing off of your screen. Well, that says the word chance right here. So again, probability, the probability of something happening, the probability of an event is a number between 0 and 1, or 0% and 100%. The same things. 100% is just 1. And it reports the likelihood of how that event might occur. So, we work with this in day-to-day life, I think. And just be careful, and something that you can use is that all the probabilities, if you add them together, they have to add up to 1, okay? Because something has to happen, all right? Two things are disjoint. We'll sometimes call them mutually exclusive as well. These mean the same thing. And this is when two events can't occur at the same time. So like if we draw a jelly bean in this example, that's both blue and purple, that can't happen. It's either blue or purple. And yes, there are jelly beans in existence that are blue and purple, but not these jelly beans, okay? That's disjoint. And we'll be able to say some nice things if we ever have disjoint events. Disjoint is mutually exclusive. Independent, the result of one event does not change the probability of the next event. So if I drew a jelly bean and it's purple and I put it back, that event does not change the probability of the next jelly bean, assuming I put it back and shuffled. But if I drew a jelly bean and ate it, that would not be independent of what happens if I drew another jelly bean. Because the color of the jelly bean I ate changes the probabilities of what's left in the bag. There's not the same number of jelly beans anymore. Okay, so that's something that would not be independent. Theoretical probability versus empirical probability is also something important. Theoretical probability means like what should happen? What do we expect is going to happen? If everything's working the way that we think it should work, what's the probability of a purple jelly bean? And in this case, we could find that by saying, well, there's 2 purples out of 10. Probability is just going to be 2 out of 10, which we will always remember to reduce to 1/5. That's the theoretical probability. Well, that's a little different than empirical probability. Empirical probability says, well, what actually did happen? And a lot of times we use empirical probability if we don't know the theoretical probability. We don't always know theoretically what should happen. Okay? Let's say that we had a giant bowl of jelly beans. I don't want to count all the colors, but I could just look at 20 random jelly beans and get a pretty good idea about the distribution. And we could use that for empirical probabilities. It wouldn't be exact, but we could get a good idea. So if we draw a jelly bean and put it back 10 times, and let's say we recorded that in a frequency table, a relative frequency table. So let's say even though there was only one blue jelly bean, when we did this, we actually we drew that blue jelly bean twice. And even though there were 2 purples, when we drew it, we only draw 1 purple total. And then there were 4 reds, but when we kept drawing jelly beans, we actually got 5 reds. So empirical probability should be kind of close to theoretical, but they're not going to be the same. Empirical is what happens when we actually did this. All right, that's the difference. So if we wanted to look at the empirical probability that something is purple, that would only be 10% or 1/10. Theoretical probability was 1/5, 20%. Empirical probability was 1/10, 10%. In general, those will be different, but related. That brings us to the last thing in this kind of welcome to probability. Here's a bunch of definitions. It's called the law of large numbers. We won't get into this too much. This is a little bit more complicated. But basically what this is saying is that if we get enough data, if we run an experiment enough times, the empirical probability will get really close to the theoretical probability, right? These were kind of close to the theoretical, but our empirical was different. We did this 100 times instead of only 10. Our relative frequencies would get a lot closer to the theoretical probabilities. If we did this 1,000 times, they'd be almost the same, okay? That's basically what the law of large numbers says. The more you do an experiment, the more your experiment is going to reflect reality, which we know intuitively, right? Small sample size means we're going to have less reliable results. And the more data we get, the more it'll reflect reality, assuming our procedure is good. But that's something else. Anyway, so this is just kind of an introduction to probability. These are some terms that we're going to reference later on. But we'll also be working with them a lot more in the future videos. So don't sweat it too much right now.